Welcome to Two Projects. In this video, we are going to explain the project Privilege Escalation Attack Detection and Mitigation in Cloud using Machine Learning. Introduction. This initiative explores advancements in cloud computing and focuses on enhancing security, specifically addressing privilege escalation attacks using advanced machine learning techniques. With the widespread adoption of cloud services, the risk of privilege escalation attacks where unauthorized access occurs is on the rise. The static nature of employee access privileges in cloud companies further escalate vulnerabilities. This project aims to strengthen cloud systems against such attacks. So, to tackle this challenge, we employ machine learning for real time detection and mitigation of privilege escalation attacks. By analyzing user behavior and system anomalies, we implement various techniques such as light GBM, random forest, ADA boost, XG boost, and more, creating a dynamic defense mechanism adaptable to the evolving cloud environment. So, the primary beneficiaries include individuals and businesses leveraging cloud services. The project contributes to data security and integrity, instilling confidence in cloud computing. Cloud service providers and enterprises stand to gain trust, ensuring a secure online environment for users. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to develop a machine learning system to detect and mitigate insider threats, particularly those stemming from the widespread use of smart devices. The focus is on tackling the growing complexity and frequency of such threats. And the goal is to propose a structured method for detecting insider threats within centralized cloud setups. The approach targets the identification of anomalies and security issues linked to privilege escalation, addressing challenges posed by centralization in cloud computing. And the objective also includes employing a tailored dataset from CERT to apply machine learning algorithms, random forest, ADA boost, XG boost, and light GBM for classifying insider attacks. The goal is to achieve robust performance across diverse internal threat scenarios through algorithmic diversity and evaluation. Requirements needed to execute this project are software requirements. Software needed is Anaconda, primary language used is Python, front-end framework used is Flask, back-end framework used is Jupyter Notebook, database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is important required libraries. So in this initial step, essential libraries NumPy, Pandas, sklearn, and Word Cloud are imported to facilitate data manipulation, analysis, and visualization. These libraries provide a foundation for subsequent tasks, ensuring efficient handling of the dataset. The second step is exploring the dataset. So, the focus here is on understanding the structure and content of the dataset, particularly the emails data. Exploratory data analysis techniques are employed to gain insights into the dataset's characteristics, aiding in formulating strategies for subsequent data processing steps. The third step is data processing. This step involves handling missing values, replacing punctuation, converting strings to lowercase, and removing special symbols, letters, or characters to standardize textual data for analysis. The next step is visualization using Seaborn and Matplotlib. So, visualization using Seaborn and Matplotlib enhances data interpretation. Visual representations help uncover patterns, trends, or anomalies within the dataset. This step ensures a comprehensive understanding of the data's distribution and relationships between variables. The next step is feature selection. So, feature selection involves transforming text data into numerical format using count vectorizer, scaling features for uniformity, and applying k-means clustering for grouping related features. This prepares the dataset for machine learning models by extracting relevant features and optimizing their representation. The next step is train and test split. Here, the dataset is divided into training and testing sets to assess the model's performance. The training set is used to train the machine learning models, while the testing set serves to evaluate their predictive accuracy and generalization to unseen data. The next step is training and building the model. In this step, various machine learning models, including Light GBM, XGBoost, Random Forest, and AdaBoost, are trained on the dataset to predict outcomes based on the selected features. And in the next step, as an extension, a hybrid model was implemented through voting classifier, which combines predictions from multiple individual models. This approach enhances predictive accuracy by leveraging the strengths of each model, resulting in a more robust and reliable final prediction. And the project extends to building a user friendly front end using the Flask framework. So, utilizing SQLite for user authentication and storage, the front end provides a seamless interface for user testing. This step bridges the gap between model development and user interaction. So, after signing in, users provide input through the front end, which undergoes pre processing steps similar to the training data. Later, trained machine learning models then use this pre processed input to make predictions, and the final outcome is displayed on the front end, offering users an accessible and informative interface. Now we'll understand about the algorithms used. So the first algorithm built is Light GBM, that is Light Gradient Boosting Machine. So Light GBM is a gradient boosting framework that works by training trees in a sequential manner where each tree corrects the errors of the previous one. It uses a leaf-wise strategy to grow trees, making the algorithm faster and more memory efficient. Light GBM is particularly well suited for large datasets and high dimensional data. It minimizes the loss function by adding weak learners iteratively, optimizing model performance. The next one is XGBoost, that is Extreme Gradient Boosting. So, XGBoost is an optimized implementation of gradient boosting that integrates features like regularization, handling missing values, and parallel processing. It builds trees sequentially, each tree compensating for the errors of the previous ones. XGBoost is known for its speed, scalability, and ability to handle complex relationships in data. Regularization techniques prevent overfitting, and its flexibility makes it widely used in various applications. The next algorithm built is AdaBoost, short for adaptive boosting. So, AdaBoost combines weak learners, usually decision trees, to create a strong classifier. It assigns weights to instances, focusing more on misclassified data in subsequent rounds to improve overall accuracy. AdaBoost adjusts the weights of misclassified samples, emphasizing difficult to classify instances. It continues iterations until a specified number of weak learners is reached or perfect predictions are achieved. And the last algorithm built is random forest. So, random forest is an ensemble learning method that builds multiple decision trees during training and outputs the class, that is, the mode of the classes or the mean prediction of the individual trees. It introduces randomness by selecting a random subset of features at each split, reducing the risk of overfitting. Random forest is robust, handles high dimensional data well, and provides feature importance rankings. So this is the performance metrics comparison graph. In this graph on x-axis I have algorithm names and on y-axis I have performance metrics scores. So here blue color bar represents accuracy, orange color bar represents recall, green color bar denotes precision, and red color bar denotes F1 score. So, accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So, the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So, this is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is email dataset file in which I have required dataset on which we will train the machine learning models. These are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store the user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, local host, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this button, the sign in button. So as I already have an account, I'm clicking on this button. So here we have to provide our credentials, username and password. And click on submit. So it has redirected us to the attack detection page. So here we can see a write the comment here box where we have to enter the text for which the application will classify it as either safe or insider attack. So I have entered the text. Now click on predict button. So here we can see the result, that is you are safe. So the application has classified the given text as safe. So if we want to try again, click on try again link here. So we'll try again giving another text. So I have entered the text. Now click on predict button. So here we can see the result, that is insider threat detected. So similarly, we can give any text and can get the detections. Now click on logout. So the conclusion here is the project is designed to effectively address insider threats, aiming to resolve the challenge of identifying and preventing unauthorized activities within an organization. The focus is on enhancing security measures against potential breaches from within. The integration of diverse machine learning algorithms such as LightGBM, XGBoost, AdaBoost, and Random Forest ensures a more nuanced analysis of insider threat patterns. The introduction of a hybrid model through voting classifier as an extension to the project further fortifies the predictive capabilities. And the incorporation of Flask and SQLite facilitates a user friendly interface, making the model accessible to a broader audience. The front end design allows for user testing, input validation, and seamless model predictions, enhancing practical usability. And the project's outcomes extend benefits to organizations and businesses seeking robust insider threat detection. The ensemble of algorithms and the user friendly front end makes it applicable in real world scenarios.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.